Okay, welcome to Earth Science, everybody. So now it's time to take some of these ideas, and again, I'd really like you to try these before you go to the next section. And if you want me to check them over, say, hey, Mr. F, I'm done with that. I'll be keeping an eye on them up here as well while you're working. And I guess maybe if you're doing this outside of class, it's a little trickier, but shoot me an email. I'm here. Let's make sure we got some of the bases down before we try to figure it out mathematically, because it'd be kind of tricky if you don't get the basics on what density is. That said, here we go. Let's do some math. So this is from the front page of your reference tables. Now, we talked early in the year about how important these reference tables are. 16 pages of earth science information that you get to use on every test, including the Regents exam. So the things that are in there are critical. You're going to hear me say ESRT many, many times. So this is scanned right off the front page of it. There's 4 equations you got to have here in earth science. And there they are. So density is the 4th of them. So there you go. Once we do this, we're a quarter of the way through the math equations for the year. So density equals mass over volume. It's like all these concepts we talked about up here. But now we just got to put some numbers to it. So as an example, I grabbed a board game piece. This is from a board game called Quirkle Cubes. So this is one Quirkle cube, I suppose. I got the mass on a balance over there, and it came out to 5.4 grams. All right, so mass of 5.4 grams over a volume of what? So I grabbed a ruler and measured the length, width, and height of this, right? Volume equals length times width times height. You'll have to do that when it comes to the lab. I guess if you want to write that, it's not a terrible idea. Volume equals length times width times height. I'd like that better if it were capital. Sorry for the delay here. It's a little better. LWH, if you know that. And hey, since we're talking about these questions, you might just need that when we get to right here. And I did already include that in the notes. Volume is length times width times height. So I did that. It's 2 times 2 times 2, which is 8 cubic centimeters, because I did that in centimeters. The metric system, you're going in different order this year. Maybe you've done the metric system lab already, maybe you haven't, but the metric system is brilliantly set up so that a cubic centimeter, 1 times 1 times 1, is a milliliter. That's what it is. So cubic centimeters and milliliters are really kind of interchangeable units. So I almost always go with milliliters on Cami here because it's really hard to do the cm with the raised 3, you know. Whatever, we do what we can. So that is the mass and the volume, right? So you grab yourself a calculator, and we'll see what the good people at the Quirkle Cube Factory set this up to be. 5.4 over 8, 0.675. So that is the density of one Quirkle cube. Density equals 0.675. You want to be careful with labels. We took grams and divided them by milliliters. You can really just like look at what you did. You can steal the work you've already done. Grams over milliliters, that label is grams over milliliters, grams per milliliter. It's the same. Don't panic. You already did the work. It's written there. So the density of one Quirkle cube is 0.675 grams per milliliter. Another cool thing about the metric system is that by default, water has a density of 1. That's how we set this all up. 1 cubic centimeter is 1 milliliter, and 1 gram is defined as 1 cubic centimeters, like that volume of water. So that's like 1 divided by 1. So water is always 1. Everything less than 1 will float. Everything more than 1 will sink. Besides the point, we're focusing on the math here. Sorry, getting off to rambling here already. Mass over volume. So let's do that some more. Here's a Regents question, or question number 30 on whatever Regents this was. What is the density of this mineral sample? So to get density, we need a mass and a volume. So mass, we're going to read right off the scale here. And again, you'll do this lab soon. You'll be using a triple beam balance. It looks to me like it is at 60 grams. Over. That's our mass. Over a volume. This is another thing you'll have to do, displacement. Now, being that we've all had kind of unique school experiences, to say the least, over the last year and a half, I'm not sure how many people have done this and how many haven't. But to figure out the volume of something that's like irregularly shaped, this was easy because it's a cube and you just do boom, 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 multiply the 3 and you're good. Something that's got an odd shape doesn't have an equation for it. So what we do is we put some water into a graduated cylinder. You'll be doing this. And we read whatever it's at. It doesn't really matter what it's at. Right here, to me, it's looking like it's at 24. There's 24 milliliters of water in there arbitrarily. It could be any amount. Doesn't really matter. Then you carefully drop the sample in and you say, hey, how much did that sample make the water go up by? How much did it displace? Well, the water went up to 34. So if it was at 24 and we added enough substance, enough volume of something to make it go up to 34, that means we must have added 10 milliliters. I went from 24 to 34, up by 10. There we go. Pretty much job done. All you got to do is grab a calculator and do 60 divided by 10. Or if you're clever with your math, you know that you just cross off the zeros. 6 over 1 is 6. Both will get you there. Or divide it with a calculator. That's great too. Okay. So that's an example of like an easier one. If you're given a mass and a volume, divide the two, boom, you got yourself an answer. Where it's going to get trickier is that you're going to have to do a little bit of algebra. And if that sounds scary, don't panic. We're going to practice some. You can come talk to me if you're stumped on them. You can talk to your algebra teacher. We'll get there. What if I gave you a density and a mass? What if I gave you this number and this number? Could you figure out volume? So like if you're in algebra class, what you would do is say, I don't know what that is. So a lot of times we use the letter X. And we say this number equals this number over X. And what I find most people like to do, and it's not mandatory, you can algebraically get your way out of this problem however you feel comfortable. What most people like to do is say, well, density over 1, because something over 1 is itself. That's cool. That's legal. And then cross multiply. Okay, we'll do it below, so don't panic yet after I get rid of all this noise. Okay, it's always going to be that equation, D equals M over V. So maybe I'm going to write that right here. Density is mass over volume. So just to make you comfortable with like how I'm setting this little table up, I actually stole this problem just to like make it easy, right? What if you have a mass of 60 and a volume of 10? Well, we've already done that in the first one. 60 divided by 10 is 6. So there we go. Job is done. 6 grams. You know what? You guys got to do whatever you feel comfortable here. I know with those touchscreens, maybe it's easy. Some people like to write. Some people prefer the text with sloppy writing. For me, I think it's easier to type. So there you go, 6 grams per milliliter. Okay. What next? Now we're going to have to do some algebra. Here we go. There's 6 examples here. It's doing the same thing. There's really 3 different types of problems. You're either missing a density, you're missing a volume, or you're missing a mass. All right, so take a minute. This is going to be like if you just try to say in my head, but if you're a real strong math student, maybe you can get that. But if you're trying to like just compute it in your head, and you get panicked and confused, then we're wasting time, right? Like just write it down. It's only going to take a second. Density is 4.3. So density equals M over V. So 4.3 equals M over V. I got a mass at 548.5, and I don't know what the volume is. And again, in algebra, people do that with an X. If you want to leave it as a V, it means the same thing. You want to use a Q, R, whatever, an emoji. It all really just means like blank, right? So 4.3 is 548.5 over X. Density is mass over volume. Density 4.3, mass 548.5, volume, I don't know yet. There you go. Solve it however you feel comfortable. Maybe pause and try it. I don't know. What do you think? Pause and we'll come back. So cross multiply. What I get is 4.3x equals, and the cross multiply thing here means that times that is equal to that times that. So 4.3x is equal to 548.5 times 1, which is 548.5. Sorry for my sloppy writing here, but so it goes. Next in algebra, what we do, we got to isolate that x. So we put this over 4.3. 4.3 divided by 4.3 is gone. We do that on both sides of the equations because that's following the rules, dividing both sides by the same thing. And we grab ourselves a calculator. 548.5 over 4.3. 127 point. Usually, like you look at what's in here and you say, okay, I'll round to that. That's probably about right. These are to tenths, so let's go to tenths. 127.55 would really be 127.6. 127.6. That's it. How you feeling? All right, let's do this one. Then you've seen all three. Again, the first one's like the easiest. Mass over volume, just mass over volume. That's a little trickier. Got to do some cross multiplying there, and this one too. So what if I have a density of 2.8? I'll switch colors here so it looks different. What if I have a density of 2.8? Density equals mass over volume. So 2.8 equals this mass. I don't know what it is. So X over the volume of 98.4. All right. Again, there it is. Algebra. Solve it. Some people have different ways. I've found through the years that most people like cross multiplying. It's not mandatory. You do you. So X times 1 is X, and that equals this. And that's going to be pretty much as easy as it is, except that I need a calculator for that. 2.8 times 98.4 is 275.5. That's it. Job done. So our mass here, 2. Well, let's type it. 275.5 grams. Well, all right, that leaves us with 3 that I'm not going to do on this video, but you are going to do. I want you to try these out. And if you're stumped, like, geez, I don't know how to do that, that's why this YouTube thing's going to work well. Go back, see what I did, and just use the different numbers. It's the same exact 3 problems over again. Okay? I want you to do that before you get onto these questions. Should I do a new video? No, I'm gonna keep going, but stop this video. I'm gonna stop because otherwise it'll get confused. I stop. Good luck. You guys are doing great. Better than me. Keep it up, and I'll do another quick video to tell you what you're gonna do down here. All right.